Hello and welcome to ML with AP. The topic for today is Scikit-Learn. In next 30 minutes, we are going to cover 30 commands which will cover 80% of your work when it comes to Scikit-Learn. But what is Scikit-Learn? Scikit-Learn is the open source, hugely popular Python library used for machine learning models. It's built on top of NumPy, SciPy, and Matplotlib for easy integration. It's one of the most popular libraries used worldwide. What makes it great? Standard framework, good documentation, and huge adoption across industry and academia. Scikit-Learn. But what Scikit-Learn is used for? If you ask me, it is primarily used for 5 different purposes. Let's see what are those. The first is we all use it for predictions. We all use for what is called estimators. So Scikit-Learn has inbuilt algorithms to build models for various regression, classification, supervised, unsupervised tasks. These are called estimators. The second thing which Scikit-Learn does or is used for is called transformers or preprocessors. So the data which it comes, if you have to do manipulation of those data, that also Scikit-Learn can do with ease. The third thing which is great about Scikit-Learn is building pipelines. Suppose you have to do a series of operations, whether it is related to estimator or preprocessors, you can put it all together into a pipeline format and you can execute it multiple times. It makes life so much easy. We'll just see that. The fourth thing is the model evaluation. So in case you have built the model using estimators, but are those the great model? How are you going to evaluate those models? Scikit-Learn provide tools for that as well. The last thing is the automated parameter search. When we say parameter here, mostly it's hyperparameter. So as you must be knowing, any model or any algorithm for machine learning, we need hyperparameter tuning over there. Scikit-Learn has some great built-in features using which you can do the automated hyperparameter tuning. Okay. With that being said, let's jump on to the Jupyter Notebook. Let's learn Scikit-Learn 30 minutes, 30 commands, 80% of the work done. The first and the foremost thing, we have to import Scikit-Learn, sklearn, import sklearn, and we should print the version. Printing the version is a standard in Python. _version _ is the method. Let's learn it. We are using the Scikit-Learn version 102. Let's jump on to the first topic, which is fit and predict estimators. Now, as I was mentioning, the estimators is something which is built inside Scikit-Learn to quickly build models, okay, machine learning models. Each estimator comes with at least 2 of the methods, fit and predict. What does fit do? What does predict do? We'll just see in a minute. But these models are available for supervised, whether it's classification or regression tasks, or unsupervised. It's available for both. Now, the fit method, as I was saying, is that when you fit the model, when you ingest the data, your dependent and independent variable, when you train the model, that is fitting the model. Predicting, when you are doing the prediction, that time you use the predict method. Let's see it in action. So the first thing we are doing, we are trying to, these 2 lines, these lines are going to help us in visualizing machine learning models being generated through Scikit-Learn. So it's a method which is setConfig, and I'm displaying it as a diagram. If what you see over here, this is coming because we are importing setConfig and we are displaying it as other diagrams. Okay, so let's move on. From Scikit-Learn.ensemble, the first example which we are going to see is from random forest classifier. Okay, so the idea of this tutorial is not to build great models. The idea is to learn how Scikit-Learn works. Okay, so with that being said, Scikit-Learn, as I was saying, that has tons of estimators. So from Scikit-Learn.ensemble, we can import random forest classifier. Now it's as the name suggests, it's random forest classifier. Building model is pretty simple over here. What you need to do is you need to instantiate random forest classifier. What I'm providing over here, random state is 0. The random state is provided just for reproducibility's sake. Okay, what do I mean by that? So sometime if I can put any number over there. Okay, I can put 42 over there for that matter. What it will be, this seed value or this random state will be used to initialize the weights. You will be used how we do the train test, a split and various things. So if you want to execute it multiple times, if the random state is constant, you can expect a similar result or the same result every time. Okay, so I have instantiated an object random forest classifier into model. Now my X is a very simple 2 samples 3 features, right? So I have 2 observations and 3 features, 1 2 3 11 12 13. Okay, my Y is also very simple. It is 0 and 1, the 2 class binary classifications. And what I will do is, as I was saying, the training part is dot fit. What I do a model dot fit. I pass my X independent and my Y dependent variables, and then I will run it. It's as simple as that. This graphical thing which you are seeing is because of I have done the set config display is equal to diagram. Okay. To do the prediction, you have to invoke dot predict method. So now model is already trained. When I have to predict, I'm predicting the same independent variable X. Let's see the prediction. The prediction is 0 1, which was my Y dependent variable also. Now if let's say I can also do model.predict for new values. Let's say I have an observation which is 14 15 16 4 5 6. Okay, for the new data. That's how the whole point of doing the prediction. When I did the prediction, it's coming. The first 14 15 16 is classified as 1, the class 1, and 4 5 6 is classified as class 0. Okay, 2 classes. What you can do instead of model.predict, you can also predict the probabilities what is being assigned to these particular classes, or how random forest classifier has predicted this. Now when I did this, you can see over here what it will do. Instead of just predicting 1 and 0, it will predict the class probability. So the class probability for the first prediction, which is 14 15 16, is 0.26 and 0.74. Okay, 0.26 and 0.74. What does it mean? That means this is the 0th class, this is the first class 1. So since class 1 predicted probability is 0.74, which is greater than half or greater than the class 0 probability, the prediction is coming as 1. Similarly over here, the class 0 probability is higher, prediction is coming as 0. Hope that makes sense. Now as I was saying that there are tons of inbuilt estimators present in Scikit-Learn. So for supervised learning estimators, we have linear models, linear regression, ridge regression, all sort of regressions. We have naive Bayes, decision trees, all the trees, even the ensembles we have over here, support vector machines, nearest neighbor, neural networks also. For unsupervised learning estimators, for the unsupervised training, we have estimators over here. We have clustering and various dimensionality reduction techniques also present over here. Let's take one more example. In this particular case, let's take logistic regression. Again, what we need to do is we need to do a model.fit. We have to define a model, instantiate a model, do the dot fit, and do the dot predict. Okay. This time we are loading the iris dataset, which is present, which is inbuilt in Scikit-Learn datasets library, and we'll import logistic regression from Scikit-Learn.linear model. What we are going to do is that we are going to load iris. Okay, and we have got our x and y variables. We have got our independent and dependent variables over here. What we are doing, we are instantiating a logistic regression object. Okay, random state is being given as 0. Max iter or max iteration has been given as 1000. So this is the number of iterations which will be passed, or how many times our the data will be passed over or iterated over is being given as max iter. And then what I will do is I will do a dot fit. You can do it separately also. You can club it together with dot fit dot xy. Okay, when we did this, let's do a prediction. So clf was our object, clf dot predict, and what I am going to predict over here, my x variable. Okay, and if you see this notation over here, that 0th and first row and all the columns I'm passing, and I'm trying to do a prediction for that. Okay, just 0th and first row, so the first two observations. Okay, and the class probability, let me run this. Yeah, this is, so the prediction for the 0th is 0, class 0, and the prediction for first row is 0. Okay, the class probability, if I have to publish for the first 100, then you can see it over here for the first 100. This one, this is in scientific notation into, so this can be read as 0.98. That means, again, I was saying that the prediction probability gives you, this is a multi-class problem. So there is a class 0, class 1, and class 2. There are 3 classes over here. My first observation is being heavily predicted as with a certainty, almost certainty, 0.98% chance of being predicted as class 0. And if you see, these are the class 0th, first and second. Class 2 is very, very low. It's 10 to the power minus 8. This is also very low, right? And that's why the prediction will be, if you just see the prediction, not the predicting probability, it should come as 0. Okay, so this is the class probability prediction for the first 100th row. As you can see, let's see the first 100th row over here. You can see the first 100th row, right? We have 4 features over here. For Y also, you can see the first 100th. Now, as you are seeing that the first 2 were correctly predicted as class 0, right? You can see it over here. To predict the accuracy also, now with each of the estimator, there are different performance metrics which are associated with it. With logistic regression, we can have something called accuracy. Now, if you have to predict or calculate the accuracy, you have to pass the x and the y parameter, the dependent and independent variable, and the accuracy is coming as 0.97. Okay, the accuracy is that how many times the prediction was or the percentage of your observed prediction versus real class, right? That will be termed as the accuracy or the score over here. Now, the second class of problem which comes or which is handled by Scikit-Learn is transformers and preprocessors. Transformers are, as the name suggests, they transform the data. They do the manipulation of data. Preprocessors, again, before you feed into the model, the data has to be transformed and preprocessed, right? So pre-processing a step, again, the imputation of data, the manipulation of data, massaging of data, all those things we can do. So in Scikit-Learn, preprocessors and transformers follow the same API model, right? So that's the beauty of Scikit-Learn, that it follows a very, very generic approach. If you recall, for estimators, we were doing the fit predict. Okay, there was a fit method. First, you have to do a fit and then predict. Similarly, for our pre-processing and transformers, we have a fit method and then we have a transform method. Okay, so we just have to keep that in mind. Now, for pre-processing, we have something called a standard scaler. What a standard scaler does, I'm sure that you are aware about normalization. So normalization can be done in multiple ways. One of the ways in normalization that can be done is standardization, and this standard scaler implements that. What it will do, is your data, it is going to um, uh, it is going to squish the data or scale the data into with mu as 0 and a standard deviation 1. Okay, so as you have the standard Gaussian mu 0 and your variance or standard deviation 1, it will try to do the similar thing, right? So this is what a standard scalar does. The formula for that would be like your x minus mu or x bar divided by the sigma, right? So it tries to squish the data in such a way that your mean is centered around 0 and the standard deviation is 1, right? Okay, now with that being said, let's see. So I have a very small again data set over here, np.array 1 2 3 4 5 6, and scale data according to the computed scaling values. So a standard scalar, and I will do the first thing. What I'm going to do is I'm instantiate the object and run a dot fit on that. Okay, and then I will do a dot transform. So it's very similar to how we used to run the fit and predict, right, in case of your estimators. The output can be shown over here. If you can see over here, most of the data are centered around 0 with a standard deviation being 1. Okay, you can change that as well. I have split into two parts. Over here you can chain it like dot fit x dot transform x also, and this also will give you the same result. Okay, let me run this. Okay, because we have reused x multiple times. Okay, so you can do the fit underscore transform. Now one of the things which you can do over here, rather than running fit and transform, you can club both of them together and you can run a fit transform method also, and it will do the same thing for you. Okay, now the question to you is, can we just transform without using fit? Is it even possible? Like you're just doing a transform without using fit on any method? The answer is yes. You can fit on some other data. Let's say if you want to do you have already done the fit on some data, and by fitting, what the transformer is doing, if you are doing a standard scalar dot fit, it is calculating for that particular data set mu and sigma, the mean and the sigma. Once it has calculated, if you run a transform on some next data, some other data, what it will do is it will try to scale your data based on the mu and sigma which was already calculated. Let me take you with an example, okay? And why this is important, you will be able to understand. Let's say I have defined a y over here, okay? Now my standard scalar, this particular object fx, if you see over here, fx, right, standard scalar dot fit, this data was already fit on which data? On this particular data, right? It is already fit, and then I'm going to run a transform on y. What mu and sigma do you think is going to be used for this particular data set? The sigma and mu, which was already created for fx earlier, will be used to transform this particular data also, and it has been used, and it will result in like that, right? Now what can be the possible use case for this? Let's say you are doing a trend test split, okay? Now you do not want to, you want to run the same transformation on train and the test set also. You do not want to do it separately. So you will do the transform one time on, or fit one time on test, on train. You can do transform on train also. But for test, you are not going to do the fit again, because it will defy the whole purpose, right? You are going to run the same fit which was done on the training, and you will just do the transform and test set, so that the same sort of mu and sigma related transformation happens both on the training and the test set. Make sense? Okay. Now let's see, sometime you want to apply different transformation to different features. Now here what is happening is we are applying the same, like since it was one column, it was very easy, right? But sometime what will happen, the use case could be that you have to apply different transformation and you have like multiple features, okay, or independent variables, and you have to apply, some are numerical, some are categorical, and you have to do different transformations on different. So in that particular case, what you can use is the column transformer. Let's define a small data frame. Okay, so I'm defining a small data frame. Let's display it. This is a data frame, so it had 4 columns over here: city, title, expert rating, user rating. The data frame is not important. The important thing is there are some categorical string like, and there is some numerical things. Okay. Now let's say if you have to do the transformer for that, or transform the data, what you will do, you can define a column transformer like this, right? So this is the name which is defined for that transformer. Which column is going to get transformed? You can mention city. I want to do city. And what transformation I am doing? I am doing the one hot encoding. One hot encoding, as you know, is like you encode that into 10000000101 and something like that, right? I think everybody knows about the one hot encoding. Now let's see, I am the title bar, right? This is the second name which I have given. And what I will do is, the title, I want to do a count vectorizer. What I'm doing, because since this is like there are multiple words which are present in the title, I'm going to vectorize this particular column, and the function or the method which I'm using is the count vectorizer. What I'm going to do for the remainder? Drop. You can do pass through, you can retain it, you can drop it. Over here I'm saying that okay, rest of the column you can get rid of. Okay. Then what I will do is, since this was defined in the object columns trans, I will do a columns trans dot fit, and I'm doing it on the x. My x is over here. Okay, I did that. This is just the visual because I did the set config earlier. I can get the feature names also printed out. Okay, so if you can see the feature names, right? The feature names means all the columns which have been getting transformed, right? Since we are doing one hot encoding, the first 3 over here, if you see the first 3 columns will be related to your categories. One hot encoding of the city. So how many city values are? London, 1 value, 2 value, 3 value. So there are 3 distinct values, right? 100, 100. The first 2 are London, and then the other city and the other city, and the rest are all because of this count vectorizer, right? So my title is being vectorized into this form over here. Make sense? Okay, let me run this, and then I just do the column trans to print it out, right? Now column transformers, this is the categories and the title bar, right? There were 2 categories where one hot encoding, and title bar was count vectorizer, just a printing of the value. Okay, so in case the bottom line is, in case you want to do multiple separate operation done on different features, you can use column transformer. Okay, now the third thing which I was saying is that Scikit-Learn is being used for is the pipelining. Now what is pipelining? Now sometimes what will happen is that you want to combine your estimators and transformers into one big pipeline. Pipeline just means that one things come out, or the input of one thing or the output of one thing is joined to the input of next, right? This is what pipelining is. Think it like a pipe, right? So that the data or your data or algorithm flows in a very particular predefined order. This is what pipeline. So think it like that you want to first do the pre-processing, then you run an estimator on top of it, and everything should be united or unified, right? For that we have a concept called pipelining, and and again, similar to your estimator and transformer API, this is also very similar. So we'll see that in action. Let's see. Okay, so for this we'll need transformer also, for this we'll need estimator also, and we'll chain them together into a pipe. Okay, So for pre-processing, we are getting the standard scaler and min-max scaler. We are getting a estimator also, logistic regression. We'll import something make pipeline also over here, and we are loading the data set just to showcase this. Again, we are doing the load iris data set, train test the split also from model selection, and we'll do the metrics, like we are doing logistic regression, we'll do the accuracy score. Okay, now create a pipeline object. The way to create a pipeline object is to make pipeline, and then you specify that what are the things which we do. In this pipeline, we are using a standard scaler. The first one is being a pre-processing transformer. The second, what we are chaining it with is logistic regression, which is an estimator. Okay, can you guess what type of transformer estimator should be changed? Which should be the last one, right? Like in this, can we do, let's say, let me show you. So if I do a standard scaler, min-max scaler, logistic regression after that, will this work? The answer is yes, it should work, because what you are doing is first you are doing the standard scalar stuff on your variable, then you are doing it to the again min-max scalar, another normalization, and then you are trying to doing a model.fit and model.predict through an estimator, which is logistic regression. Let me run this. Oh, okay, something went wrong. That means what I have done over here, yeah, I have to run this one. This ran. Okay, now let's see the next cell. In this particular cell, what I have done is I have switched this order of min-max scalar and logistic regression. So I have a transformer over here, I have an estimator, and then again a transformer. Will this work? Let's see. Oh no, this has an error. And now this error is very intuitive, right? Why it should be? Because what you are trying to do is you are pre-processing, transforming, then you are doing an estimation or prediction, and again you are transforming, which doesn't make any sense, right? So what the rule says is all estimators in a pipeline except the last one must be a transformer. Only the last one can be an estimator or a transformer. The last one can be an estimator or transformer. Rest all should be a transformer. But over here, the second one is not a transformer, it's an estimator. It doesn't do the fit.transform method, right? It doesn't have those methods. And that's why this error was there. As you can see over here, see, all intermediate steps, all intermediate means not the last step. All intermediate steps should be transformers and implement fit and transform to the string, okay? Logistic regression doesn't. Logistic regression is an estimator, it's not a transformer, and that's why the error. Make sense? Okay, now let's see. Load the iris dataset. We have done the iris dataset and train test split standard stuff. And then what we'll do is we'll do again for pipe also the API and the how it is used is very similar .fit. Okay, so we are doing the fit to this pipeline this time. Okay, it's train by train. And since I have done the set config, it will do a graphical display also. We can now see that the other estimator, let's say accuracy score, if you want to get, and we can very well get the accuracy score over here. Okay, so this is how the pipelining works. The fourth thing which Scikit-Learn does beautifully is the model evaluation. Let's see how it does. Okay, so fitting a model to some data does not mean that the prediction power will be great, right? This needs to be evaluated and tuned, right? So Scikit-Learn provides many tools for model evaluations. Okay, and the way it does is mostly through cross validation. Okay, so I'm sure that you know about cross validation. If you do not know about cross validation, please read it on the internet. In a nutshell, if you have to see in 2 lines, that cross validation is that you have done a model, now you want to evaluate the same model or cross validate the same model by dividing the train test split multiple times from the same data and see that, okay, my it's not the accuracy is not going down because of your high degree of uh, it is not memorizing, right? It is not memorizing the data, or the for the unseen data, or for the newer predictions, the data which it has not seen. Now my prediction power should still be good, right? So it has something to do with the bias variance trade-off also, right? So neither the model should have the high bias nor the high variance. Okay. So with that being said, let me stop on the cross validation. But how the cross validation is implemented using scikit-learn, let's see it over here. Okay, again I'm again the data set, you can get back regression. Okay, this will generate the data set for the regression linear model. I'm doing a linear regression this time, and we'll import the cross validate. Okay, so what we are going to do is we are going to get 100 samples, n samples, and we are going to get the n samples into xy, my training, not the train, but my dependent and independent and dependent variables. Okay, and I have defined a linear regression. Okay, let me run that. The second thing is the cross validate. What I'm going to do is that I'm going to pass my linear model or the linear regression over here along with x and y. Okay, and the default is 5-fold cross validation. That means my entire data will be split into 5. At any point 4 sets will be used for, or 4 subsets will be used for training, 1 will be used for evaluation. Okay, or for the testing. Let me show it to you. Okay, yeah, you can see the signature for the cross validate over here. It says, yeah, CV. Okay, yeah, if I do not mention CV, that means it will use a 5-fold cross validation. 5-fold or 10-fold cross validation is very normal, so we are using the default 5-fold. Okay, my x is over here, my y is over here. I'm trying to do a linear regression, and then I will do a test score. Okay, now my test scores is r squared. Since it's a regression problem, I'm getting a r square, right, as my test scores. And as you can see my test scores, one thing which you notice that there are 5 test scores, right? Now why these are 5? I just ran one model, why there are 5 outputs? So that has to do with the cross validation. I was doing a 5-fold cross validation, so my first fold accurate test score or r square is this, second r square is this, third is this, fourth is this, fifth is this. Now you can see that there is a great deal of variation which is happening. Okay, so I need to do something with this, but hence this tutorial is not about building a great model, but this is the thing, right? Like you need to do something about it after that. Okay, but this is how you do your cross validations, right? So fifth and the last thing which Scikit-Learn does great is the automated parameter search, and by that I mean your hyperparameter tuning. So any model will have certain hyperparameters associated with it. It's kind of an art and science to get the right value of hyperparameter to extract the best performance from the model, right, or tune the model. That's why hyperparameter tuning is very important. Scikit-Learn does it mostly by grid search and randomized search CV. Let's see that in action. Okay, so over here if you see that we are getting a California housing data set. Again, this is an inbuilt data set, and we use random forest regression. We are using the randomized search CV. We'll just see that in a minute, that what the randomized search CV means. Train test is split, and this is the random in generation, nothing great. Okay, what we'll do is that we'll get that or train test is split done over here, right? So x train, x test, y train, y test. Okay, now with randomized search CV, and this is the similar to grid search CV, the only difference is that in this particular case we are not going each and every in or hyperparameter space, but we are randomly selecting the values. So let's define the boundaries of our hyperparameter space. So we have 2 hyperparameters, the how many estimators we use for the random forest regression, and what should be the depth of the tree, right? So over here we have to pass a dict. In that, the first n estimator is that between 1 to 5, let's say that any value between 1 to 5 we have to pass, okay, and max depth should be between 5 to 10. This is my search space, right? Inside that, what I'm trying to tell randomized search CV is that you only do 5 such iterations, right? Randomized somewhere with a combination of n estimator and max depth, which is defined by this. You take 5 iterations, okay, and or 5 sampling out of it, right? And then try to understand or guess that which is the best parameter for my model, okay. Again, over here I am passing my param distribution, so my hyperparameter space I am giving it over here, and let me run this, and then I am doing a dot fit over here again on my estimator. Now it will go and evaluate, let's say, and so what I will do is that I will try to search the best parameter randomized search CV has given me. It seems that the best parameter is with the max depth as 9 and estimator value as 4, okay. So with this best parameter value, I will do the search score, X test, Y test, right? And this is what my with max depth 9 and n estimator 4, this is the score which I am getting. And this search is actually getting you the best estimate of your parameters also, or hyperparameters also. The other way to figure that out is the search.bestestimator underscore dot score. Again, it will result in the same thing, exactly in the same thing. Okay, so this is how you do grid search, randomized search CV. In case of grid search CV, it will change the kind of dict you are providing, which will change, and instead of doing the 5 random or randomized sampling of the hyperparameter space, you will go through each of in the grid, you will go through each of the space. That's the only difference with the grid search CV. So with this being said, we have come to an end of this tutorial on Scikit-Learn. Hope you learned that what are the 5 great things which Scikit-Learn can do, and have an understanding of how to achieve it. With that being said, I do have a favor to ask you. If you have not subscribed to my channel, please do so. It will mean a lot, and share it with your friends also. Thank you.